I spent years learning AI the hard way, coded neural networks from scratch, learned math I never used once in a real job. Then I got mentored by Yoshua Bengio, the godfather of AI, one of the three people who created the deep learning revolution. I started networking with people like Kat Madalak from Y Combinator, Michelle Zatlin, the billionaire COO of Cloudflare, and I saw how differently they thought about this. What they said mattered versus what I've been wasting time on. Completely different. Now, I make over $200K a year as an AI ML engineer, even without coming from a traditional tech background. So, if I had to start over today, I'd skip over everything I taught myself and just follow what I learned from them. This video is that faster path. Let's go. The problem today is that AI learning landscape is completely overwhelming. There's a new tool every week. Most roadmaps are outdated and designed for researchers. People spend months on math they'll never use. There's tutorial hell, basically watching everything, building nothing. You're going down a rabbit hole, just click on every new term that you hear. And there's no clear filter of what actually matters versus what's noise. What's the signal from the noise? That path worked probably 5-10 years ago, but that doesn't work today because models actually exist and you can just build from them. You don't have to build them from scratch. So think about this for reframing your mindset on this. You don't need to become a researcher, though you can if you want to, but if you want to actually become an AI engineer, you want to become a builder. Models already exist. It's been like 10 years since people have been building models. There's a lot of them out there. They're coming out every week. Your job is just to use them to solve problems, chain them together to get an actual result. And learning just in time, that beats learning everything, going down a rabbit hole, trying to learn absolutely everything. The game changed completely. Frameworks do the heavy lifting now. You don't have to build the models. You don't have to know all the math. It exists. You have to build the frameworks to go from the input to a tangible output at the end. And you want to focus on implementation, not theory. Speed comes from knowing what to ignore. That's the secret here. I had to learn things the hard way. I learned AI about 10 years ago. And back then you had to code everything from scratch. You didn't have already made frameworks like PyTorch or TensorFlow. You actually had to code all the network architecture yourself. Now, make 227K salary plus. I have Apple, Meta, Netflix, Amazon reach out to hire me and without me even applying. And I built AI for Apple Vision Pro. I built self-driving cars. And after I got a CS degree or computer science degree, graduated with honors in specializing in machine learning and AI. But I did that after I already worked for AI. And mainly I got that to basically validate what I knew. However, all the classes I took, I already knew them. Everything I did it on real projects 5 years prior, working on actual projects for real companies. Now, the thing is, what is important is what you need to know what actually matters versus what's all the academic fluff. When you're looking at papers, you actually have to be able to apply it to real world scenarios. If I was going to learn today, here's the fast path that I would actually do. I would take a 3-month plan. First month, I would actually learn Python for data science, not just general Python. Of course, you have to know the basic things, but the main things you want to learn if you're going to work in AI, ML, or machine learning is NumPy, right? This is going to learn about arrays, operations, reshaping, and like broadcasting, basically the numerical calculations. If you want to compare, Python as a general language is slower than, let's say, C++, but if you use if you use NumPy, that will actually speed it up. And all pretty much papers and whatnot uses PyTorch and NumPy, so it's fast enough to get the job done. Next, I would learn Pandas. All these things are actual Python modules, or that comes with Python, it works with Python modules or packages that you could actually bring in or import. So Pandas, think of this is for like data cleaning, manipulation, real world messy data. But basically think of it as you could bring in your spreadsheet, like an Microsoft Excel sheet, or export it out as a comma separated value and manipulate the data with that. And then the next thing is Matplotlib and also Seaborn, which is built on top of Matplotlib. And that's to visualize so you could explain to non-technical stakeholders like the executives, clients, and whatnot. The other thing I would say you could use is basically learn how to use Jupyter Notebooks or Jupyter Lab, but you could also use Google Colab or Google Colaboratory. It's free, there's no setup, and actually has free GPUs in it. So if you ever made a Google Doc before or a Google Sheet, if you actually go down, there's more options, and one of them is Google Colab or Google Colaboratory. That is a free Jupyter Notebook that you can actually code directly in there and it's free as long as you have a Gmail account, right? And the main thing I would say in the month one to actually solidify to make sure you learn what you know, that you're actually doing something and applying these packages is to build something small that processes real data by the end of the month. It doesn't have to be like super useful. It just has to work end to end that uses these packages to solidify your knowledge. Now, month two, that's where I start learning more classical machine learning algorithms first. And there's another package that's you could get with Python. It's called scikit-learn. It already has pre-built algorithms in there, and so you don't have to reinvent the wheel. So basically, you would start with like all the boring stuff that if you ever did statistics, there's a lot of these algorithms that still work on data like linear regression, random forest, XGBoost. And basically, you can learn the basics, the general workflow of how you train neural networks. You have a train, test, split, cross validation, feature scaling. You learn all this stuff using scikit-learn. And the key thing about that is it's basically establishing a baseline, meaning go from end to end, get something working, and see how well it actually makes predictions or the model performance with just these classical algorithms before you start going complex. And the thing is, these algorithms may be boring, but actually a lot of the times they work and they actually make money for businesses. And a lot of businesses they want to use AI, but they're not necessarily AI companies. They just need something to actually process the data. And this is good enough for it. Now, month three, this is where you start learning more of the modern stack and more of the state of the art and all the things that you hear that's on social media and the buzzwords right now. One, PyTorch right now is kind of like the de facto go-to industry standard for the state of the art papers. They use it right now. The thing is, you can use other frameworks for deep learning or neural networks and whatnot. It's just that if everything's already done this way, that's just one less step to try to convert it to another language. And the one thing I would say is understand the transformers architecture conceptually, because this thing is like there's a paper that came out. It's called "Attention is All You Need." That is actually what is driving the driving force with modern AI model architectures today, at least to this point. And I would say is to understand it conceptually. You don't have to build it from scratch because you're not necessarily trying to be a researcher. You just need to understand how it works because a lot of these models are derived or borrowing from these ideas or using transformers. Then you want to learn LangChain. This is basically a Swiss Army knife for large language models applications. And also what makes these models useful to companies now is RAG and agentic workflow. So learn what these are. These are where the jobs are right now. And this is what makes it possible and actually attractive to companies. And at the end of this month, you want to actually build something that actually uses LLMs to solve a problem because that is where the direction everything's going. Now, throughout these months, you're going to want to learn just not generic, just pretty much engineering skills that if you're going to work professionally, you're going to need. And that is like version control. That's Git. Git or something equivalent for that. That's non-negotiable if you're going to work on a team or even work on your own code base. You have to be able to iterate, keep track of it, revert back. Virtual environments. This eliminates this works on my machine problem. So basically you could set up an environment for your current project and create another virtual environment for another project. And you don't have to worry about the installations actually clashing with each other because you have the right versions for your project, for each package that we mentioned here, like Pandas, NumPy, or PyTorch or scikit-learn, things like that. And then the Docker, because learn the Docker basics because you can actually containerize. Think of it as kind of like putting everything on your computer, but containerize that, package that up, and deploy that. Because then you could scale this up to put it on like cloud, like learn the cloud basics, like AWS or cloud, Google Cloud platform or Microsoft Azure. Because basically production machine learning, they run on the cloud, not your laptop. So you might develop on your laptop, but you want to scale it up and actually deploy it and make it accessible to everyone. And in general, you want to learn like APIs like Flask or Fast API because the models you build in the back end, a lot of the de facto setups is you could actually do a back end and a front end that's web-based and you could put in the cloud. That's basically how your model talks to the world. Unless you're doing something more specific, but that would be more company-wide, the generic way. Even if you're developing it, you're probably going to do it this way because web technology is universal. It works on every device, works on every operating system. If you're going to do it on other platforms, you're going to have to learn that specifically, but at least prototyping, that you get something working end to end with this. Honestly, these are my recommendation and of things I would actually skip entirely if I were starting out right now. Right now, I wouldn't go into the deep math. Like actually build machine learning models, you have to know calculus, linear algebra from scratch. You have to know matrix. Well, linear algebra is math and like statistics as well. Unless you're becoming a researcher and you're actually building these models from scratch, you don't need to go deep into this. You might have to know the general idea just so you understand how neural networks work, but you don't have to master these things unless you're going to become a researcher. You want building neural networks from scratch. Again, unless you're becoming a researcher, I wouldn't worry about this. 10 years ago, they had no option, but now frameworks already handle these things. You just have to understand how it works and how they interface with it. And trying to learn every single framework that I wouldn't recommend. Just pick one and understand it, go deep, because if you have to work with another one because of a job or a certain project, knowing one, they all work pretty much the same way. They just have their own idiosyncrasy, but the underlying fundamentals work the same way. You could transfer it, look for the equivalence on the other end. And again, me starting out and I'm actually trying to get in the industry, I wouldn't necessarily focus on Kaggle competition. Again, if you're trying to be a researcher and you want to practice all types of things, fine. But if you're trying to get it to work, I would actually focus on real problems in your domain or domain that is actively looking for a solution, AI solution, and try to solve for those actual real world problems, then dealing with Kaggle competitions, right? Real problems will definitely beat out artificial benchmarks. And the other thing is perfectionism. Like, I wouldn't say try to be perfect and get everything out the way. Progress over perfection. You want to keep it moving. And you might have people say that's not the best way, it's not the optimal way of doing things. But the reality is, like, my non-optimal solution beats your non-existent perfect one, right? If you have a version that's not perfect, but it's actually working versus a theoretical perfect version that doesn't exist, who do you think the companies could actually go with, right? And the last thing is feeling until you're ready to start applying for jobs are out there. You'll never be ready. There's always something new. Every week there's something new coming out and you'll feel like, oh, I have to learn all this stuff. Actually, this is why solving real problems matters, because they say, hey, we solved this problem. And I mentioned earlier, you can solve a problem that might not necessarily use the latest state of the art. It might just use one of the classical algorithms like linear regression. But if it actually solves a real world problem, a business problem, that is more attractive than if you know everything and your resume is perfect and is flawless. Showing that you could actually solve the problem that they have is a lot more valuable. Here are a couple of things to keep in mind to help speed everything up. Clarity in your head beats cleverness in your code. The main thing you want to actually do is be able to convey what you need to get done, especially to a team and also the executives and stakeholders. Being clever in your code doesn't really help anybody if nobody understands it, right? The other thing is learn just in time, not just in case. So don't go down rabbit holes trying to learn everything. Learn what you need to get by and move on to the next thing, right? The other thing, small wins compounds. Everyone sees all the flashy, big name, all the hot buzzwords at the moment. But what you want to do is to solve small wins. A lot of the things are small, tiny scripts that change, I would say, my life. But a lot of people, again, a lot of companies are not necessarily AI companies. They're just regular companies trying to solve their problems with AI. And a lot of small things like renaming a file and reorganizing it and putting it into a certain folder sounds simple. But for a company that has like a backlog of 20, 30 years of data and have someone manually do it, or they just don't have time, something like this is a huge benefit to them and worth a lot, right? And if you add all these things up, it can greatly increase the company's efficiency, right? So look for small wins and they compound to something bigger, right? The other thing, domain experience is your actual superpower. So when you apply it to AI positions, use what you already know, because if you already know the domain, you know what is the pain points, you know what success looks like, you could speak to it and know exactly how to apply the AI. If someone knows how to use AI, but they don't know the domain, there's nothing they could really do in that domain until someone explained it to them. And even then, someone in a specific domain might spend years honing their skills in terms of going to school for it, and then the years of experience. And that's not easily transferable to someone just because they know AI. But if you know that domain plus you know AI, you become extremely valuable and companies will reach out to you. And the other thing, implementation beats theory every time. So companies don't want to hire that you know AI. They want to show that you can apply AI to actually solve their problem. So you want to make sure you have real implementation. And the other thing, the biggest thing, especially when you start out, with myself, you feel like stupid 80% of the time because you literally don't know it. So of course, that's normal. You don't know anything at the beginning, right? The thing is, you could fail 1,000 times, but you just need to succeed that one time, and that changes everything. In fact, if you look at training a model, you'll see that it's it's like going down and it's trying to like converge to a solution, and then all of a sudden it converges and everything works. And all this time, you could fail like 5,000 iterations, and like it looks like it's going nowhere. Then all of a sudden, everything works and everything just clicks, and everything just works out at that point. It's the same thing when you're learning out here. At the beginning, everything seems wrong, and then all of a sudden, everything works, and all these things compound, and you become extremely useful. And this feeling turns around. Instead of feeling stupid, you feel like you know everything because you're not learning from your failures. Although, but we're not, a failure is not a failure in itself. You actually learn from it and you know basically what not to do. And you take a different direction. And you do that enough times, you find the right path. Here's the mindset to have when actually learning how to do AI. One of the things that people would say to themselves, and I've said it myself, is that I don't have time to learn everything. And the thing is, you don't need to learn everything. You just need to filter what's important and focus on that. The other thing people say is, well, I'm not good at math. Well, nowadays you don't need to be unless you're trying to be a researcher. But it's been like 10 years since a lot of these models exist. Frameworks already work and handle it. You just have to know how to put them together. And the other thing as well is that there's too much to learn. Every week there's a whole new set of AI tools that come out. But this is why you focus on the 20% that actually matters to solve your actual issue or problem that you're trying to solve for companies or what you want to be known for. Other thing is that, especially in the last couple of years, people say I tried before and fail. You probably were just following like the researcher path where if you try to look up how do I learn AI, and then you start learning all the math, calculus, statistics, linear algebra, like matrix math and all that. That is trying to be a researcher. Now you're just trying to put these models together to actually solve a real problem. And again, the other thing is people say the field moves too fast. Yes, it moves very fast, but this is why you're trying to learn the principles, not just the tools, because you're not going to use every single tool. It doesn't solve every single problem. And as you know, a lot of times, especially if you went to school and you learn a certain profession, when you actually get on the job, you're only using a very small fraction of that. It's the same thing here. You want to learn the principles, but depending on what you're working on, you know what tools to use, and you're pretty much going to focus on that. You don't need to know everything in the field. Here's your action plan. Start today. You don't need to go and buy an expensive computer or buy expensive software to learn how to use all of that. If you have the internet and you have a Gmail account, you could go in and get Google Colab. It's the same place where you go and create a Google Doc or a Google Sheet. There's more options in there, and you'll see Google Colab, or may call Google Collaboratory, changing the name. And you want to write your first script directly in there. If you have the internet connection, you could build this out. And yes, you could do full code that works directly in there. You did even have GPU access. The other thing is you want to use your domain knowledge plus AI. That's your superpower that nobody else has. And that's what's going to make you stick out from the competition and be the prime candidate because you actually know that domain space, the pain points, what success look like, and how to speak to the stakeholders and speak to the business value of the company. And once you know these things, you're able to build out and start scripting and learning the plan and figuring out your domain knowledge and how you're going to use AI in it. The next thing you want to solve is what problem are you going to solve and make yourself valuable and show the business value to companies.